Hey, hi guys, good morning. Good morning, good evening.
Good morning, sir.
All right, so we'll get started. Okay, in the last class, we discussed about central tendency and we discussed about three measures, mean, median, mode. Mean is nothing but the arithmetical, also called as arithmetical mean, which is nothing but the average. Median is nothing but the central point or the central value of an array, while the mode is the value which is the most frequent occurring value in the array. Okay, and we discussed about how to use each of these measures, in what all scenarios we use median, we use mean, and we use mode. And later, once we discuss about some more real world use cases, then we will further, um, touch all these concepts and we will discuss in more detail. All right, so just a knowledge check. So which is more sensitive, guys, out of these three measures, mean, median, or mode?
Me.
Why so?
Mean, sir. It is sensitive to extreme points.
But why? How? It is.
Calculate mean we have to consider each and
Yes,
every data.
yes, yes. So in the calculation, we will consider all the values, and that's the reason it is considered as sensitive, because if there are any extreme values in the data, then it will get affected by those extreme values. All right, so we discussed about mean, median, mode. These are the three most popular measures when it comes to central tendency. Now the fourth another important measure in the central tendency is known as percentile. So, guys, have you heard about this word percentile? Or do you think it's the same as percentage, or do you think it's different?
It is different.
Okay. So, why is it different, and what exactly is this percentile? So, I will not show you the slide. Yeah. First of all, tell me, have you come across this word anywhere? In any context, have you heard this word percentile? Yes, it's different. It's different than percentage. That's correct. Nobody has heard this word percentile. There are few people, who might have appeared for any competitive exams, right? SAT or CAT, GMAT. Has anybody has appeared these exams? Yes. Now, the people who are in US, probably they might have definitely they have attempted these exams. So there, I'm not sure whether you have heard the word percentile. There, your position is or your score will be given in terms of percentile, particularly in the CAT exam, which I have given. So there you will say there they will say that your score is 95 percentile. So now this percentile is different than percentage. Now first tell me, what is percentage? So if my score is 95 percentage, then what does that mean? Why is this a simple question?
It's out of 100, like,
Yeah.
uh
95 questions I have answered correctly, right? So that's
yep,
95 percentage.
yep.
Okay, when it comes to percentile, it's a relative score. So what relative score is? Now, for example, 100 people have appeared in the exam, and some few people they have scored 70s, few people they have scored 75, 65, 60. Nobody has crossed, let's suppose, 80% or 80 percentage or 85 percentage. Now here, let's suppose the top score is 76 percentage. Okay. Now you have scored, let's suppose, 74 percentage. And between 74 percentage and 76 percentage, let's suppose there are 5 people. So your relative position would be 95 percentile. So that means there are 95, if there are overall 100 people, then there are 95 people below you. So your relative position is at a 95 percentile. Okay. So why in these competitive exams, these percentiles are used instead of percentage? First of all, they will take the highest score as the benchmark, and from there they start scoring. Okay, so and then they will see at what position you are based on your score. So your score, where exactly it is lying, okay, in terms of everybody's score, and based on that, your position is being decided, and based on that, your scoring is done. So if it is 95 percentile, so that means there are 95 percentage of people, they are below you. Only 5% of the people, they are above your score. Okay, and another reason is in this CAT exams, in this competitive exam, with a small um, uh, difference in the score, your positions may change a lot. So for example, somebody has scored 66.7 percentage, and there are many people who have scored. So they will go with 3 or 4 decimal places also. 724 and 721. Okay, 66.70, then 65.95. So like that. Okay. So with a small change, your position may vary a lot. So if it is like, they will call a percentage, saying that okay, this guy has got 66.7 percentage and another person has got 66.6 percentage. It does not look a big change or big difference in the score. But in between this, there could be 10 or 15 people, because of which your relative position may go down with a minute change in the score. Your percentile might go down. So in the CAT exams, in this competitive exam, with a small one wrong answer may drop your score, percentile score a lot. Okay. So that's how, in the competitive exams, majorly, and most of the time they talk percentile, they don't say percentage. Okay, so by now, you might have understood that this percentile gives you the relative position of the particular value. Okay, and okay, so I'll move the slide. Yeah. So what it does is it divides the entire data into 100 parts, and from that 100 parts, it will see that okay, the particular value lies where, at which position, whether it is at a 99 percentile. So 99 percentile means 99% of the values are below that particular value. Only 10% of the values are above that value. So example, 90th percentile indicates that at most 90% of the data lie below it, and at least 10% of the data lie above it. So when we talk about median, median is another word of the median is 50th percentile, because median being a central value, so 50 percentage of values are above the median and 50 percentage of the values are below the median. So median is also called as 50th percentile. Okay, it is applicable for every kind of data. So here comes point where we should understand what this ordinal interval ratio, nominal, all about. Okay. So when we talk about data, so data consists of variables. So variables, you can consider it as a column, basically, columns or fields. Okay. So for example, in any table, For example, first name, last name, age, income, all these columns you can consider it as a variables. So why they are named as variables? Because here the values would vary, okay, row by row. So it's not one single value which you will find in entire column, right? If it is there, then it does not make any sense because it is not giving you any information, right? So if the values are changing, that means every row is different and every row has a specific information which that particular variable is capturing. So when it comes to variable, now typically variable is of two types. One is continuous variable, second is categorical variable. Now let me put it in this way, okay? There is one column, okay, in a table. Now this column can take either a numeric value. For example, now I will talk about age. Okay. Now age could be 22.5, 21.0, 19.6, whatever. Okay. So it can take any numerical value. Now that is called as continuous variable because here the values could be continuous. Okay. It can take any value between a particular range. Now the second, let's suppose gender. Okay, if I take now here it will take only two categories. Okay, male or female. So here it is. These are known as categories. It cannot take any value. It has to take a certain values only. For example, category, product category. If there are four categories of the product, then every product has to be categorized under these four categories only. You cannot add any other fifth category to it. So these are known as categorical column. Now, in this categorical column, the data is divided, again, the variables are divided as nominal or ordinal. Okay. Now, nominal is what is where the categories are not interrelated or they are not having any kind of hierarchy. Okay. So, for example, male or female. So you cannot say that male is superior, female is superior. Okay. So both are independent and both are like equivalent categories. Even the product categories also. Okay. Every category is independent. Okay, so in that case, those categorical columns are called as nominal. When it comes to ordinal, so for example, you have given a what do you say rating to a particular movie. So you can give only 5 ratings, up till 5 ratings, 1 till 5. So now here the ratings, here the category, okay, are interrelated and they are there is some kind of hierarchy, okay, and their ranking is there. So there's some order. So if somebody has rated 2 and somebody has rated 3, then you can say that, okay, the person who has rated 3 has rated high on that particular product or that particular movie. So there is an order to it. So for example, you might have given a lot of surveys, okay, you have filled a lot of surveys. In that, people ask like whether you agree this particular statement or not. So then there would be an option like disagree, somewhat agree, neutral, or agree, or strongly agree. So now there is an order. Okay. So these categorical column will have a categories which will have no relationship or there is no order in place, then it is called as nominal. And if there is an order, then it is called as an ordinal. Now, in the data, you have to clearly identify which of the variables are continuous, which of the variables are categorical. Again, in the continuous, you may find discrete. Discrete means these are the numerical values which will be in the form of countable numbers. Okay, they would not be in the form of decimals. So there would be a discrete and there would be a floating values. Okay, so now interval means these continuous values, you can convert that into intervals. You can convert that into bins. So for example, age. So now you can create an interval like the age group between 10 to 15, then 15 to 20, 20 to 25, and then accordingly you can categorize this numerical column into intervals. Ratio is nothing but a float values or decimal values. If your variable is taking any decimal values, then it is considered as a ratio data. Now, this percentile is applicable for ordinal, could be applicable for interval and for the ratio. Why? This percentile is only applicable on those variables which can be sorted, which can be ordered. Okay, so in the ascending or descending order. For that data only, you can find out the percentile. For example, scores I mentioned. Firstly, you need to sort it out. Okay, then only you can identify how many values or how many data points are below a particular value, right? If you can't sort it, any particular variable, then it is you cannot apply percentile on top of that. As ordinal data, it will also have an order, okay, in place, then you can sort that data. Definitely the continuous data, which is in the form of numeric, you can sort that data. The nominal data is the data which you cannot sort. Okay, if you cannot sort, then you cannot apply or you cannot calculate percentile on top of it. So it is not applicable for nominal data. Okay, so now how you can compute percentiles? Now you can compute 90 percentile, you can compute 95, 80, 85, whatever. Okay, so with this single formula. So what it does is it gives you a index of a value. At that index, you will find out that percentile value. Okay. So for example, now you want to find out 50 percentile value. Okay. So basically, which is median. So you can say I equal to 50 by 100 into number of n is number of values or number of data points. Let's suppose if you have 25 values, okay, in your data, so it would be 50 by 100 into 25. Okay, so whatever value you will get, that will become the index of that. So in all the 25 values, that particular index, you go to that particular location. For example, let's suppose 12th. I is equal to 12. It has come. So the 12th position value would be your 50th percentile. Okay, so like this, with this formula, you can find out, determine the percentiles location. Okay, so if I is 10, then it is a 10th position. If I is 11, then it is 11th position. And you go to that particular location of the data, to that particular value, and that would be your percentile value. Okay. All right, so let's take some example. So first the data, and here the first step is very important. You have to order the data. So these are the data points. Now you're ordering it. You ordered it in the ascending order. Now you're finding out the location of the 30th percentile. So you put that into a formula. So there are 8 data points. So 30 by 100 into 8. So 2.4. Now it is not a whole number. Okay. So if it is not a whole number, you will take I plus 1. Okay, which is 2.4 plus 1. And now then you round that particular value. So now if you round it, so it will become 3. Okay, so now you go to this third location, which is 13. Now that will become your 30th percentile is at this particular ith location, which is third location. So it is 13. So what it says is there are 30 percentage of the values are below this 13, which is these two. And the 70 percentage of the values are above this point. Now, why is it important, for data and analysis? We will understand. Okay, with this percentile, we will get a lot of information about the data distribution, how the data is distributed, and which is very, very important for you to understand, to know the quality about the data. Okay, so if there are so many values are above certain point, okay, with that you will understand how the basically uh, a particular state is performing, right? In the business, if you're taking the sales, if the 95 percentage of the values are below particular sales value, so that means your business is kind of not doing a better, is not performing better. Okay, because most of the time your sales are below $1,000. Okay, 95 percentage of the times. Okay, so in that case, by looking at the data, you can understand how the particular state is, how it is performing, and then based on that, you can take a lot of meaningful decisions. Okay, so that is about central tendency. So here we are talking about one single number. Okay, with one single number, we will understanding, okay, how the data is looking like. Okay, with a mean, we can understand how the data is. Okay, if there is extreme values, the mean will get impacted. Then if we don't want a particular measure to get impacted by the extreme values, then we can go with mean and mode. And the percentile, with the percentile, you can look at any position. Okay, you can look out for any location and you can identify the value. Okay, so these are measures, and the practical implementation we will see when once we come at the use case. For now, you just understand these concepts. Now comes the second important measures in statistics, which is measure of dispersion. Now, currently, by these central tendency measures of central tendency, we were kind of identifying where the mass is located, how the data is balanced. Okay. So, for example, I'm just taking an object. Okay, this is like object. Okay. Now, this is like a fulcrum. You are balancing this particular object. So, basically, this fulcrum is known as these three M's: mean, median, mode. And this percentile is like movable fulcrum, which you can move at any point. Okay. And based on that, you can identify the point at which, that particular uh, uh, percentile is located. Okay. So now these are the ways and means through which we can understand the data points. Okay, so majorly if you are measuring the central point, then you have to go with these three measures. If you are going at any other location, then you can use percentile. Now comes the dispersion. Dispersion is all about this entire data. Okay, how this data values are varying with itself. So here we are not focusing on every value, how they are differing, how they are, changing uh, from other values. But here in the dispersion, we will give importance to every value and see that how the values are changing. Again, this will give another different kind of insights about the data. So it will give me, it is the measure of the variability, how the values are varying in the variable. Okay, that we can measure, we can quantify it, and we can also describe how the spread is. Okay, how the data is spread and what is the kind of dispersion in the whole set of data. Now, once we understand this measure of central tendency, on top of this, if we also add this measure of dispersion, then we will get the complete understanding about the data and we can rely on the central tendency. For example, now if I say mean, now mean is, let's suppose 33. Okay. Now the variability, if it is low, then I can go and rely on this particular mean. But if the mean is 13 and the variability among the values is very high, then I cannot go with mean because you know that mean is sensitive to values. If there are too much of variance in the data, that means there could be a lot of extreme values might be existing in the data. In that case, I cannot rely on mean. I should go with median or mode. So that's something reliability I can achieve with this measure of dispersion. Okay. Now, just look at this. Okay. So let's suppose I am dealing with the cash flows. Every day on day, I'm getting certain cash flows. Okay. So if you see on daily wise, my cash flow is exactly the same. Okay. So I got this kind of mean. So here the variability is no variability at all because all the values are same. So for example, 20, 20, 20, 20, if I consider, now the mean would be also 20. Okay. So 80 by 4 is 20. So mean is also 20. But here in this case, let's suppose it is 10, it is 20, this is 50, this is 15 or something like that. Now let's suppose, don't go by the values. I took some random numbers. Here also, let's suppose I'm getting mean equal to 20. Now here the entire meaning of this mean may change. Okay, because here there is a variability. Okay, so if I say 20, here I may get wrong, okay, if I go and estimate it, because here I have extreme values. Sometimes my cash flow is just 10, and sometimes it is as higher as 50 or 60. So in that case, I cannot rely on mean because there is too much of variability. So if you add this measure of dispersion along with the measure of central tendency, then it will give you altogether a different perspective and different insights. Okay. And based on this variability, you can decide whether you should rely on this particular measure of central tendency or not, whether you should rely on mean or not. Now, what are those measures of variability? They are multiple measures, but the common measures are range, interquartile range, mean absolute deviation. In short, we call as MAD. Okay. And then the variance, then the standard deviation, z-score, coefficient of variation, and so on and so forth. Okay. So there are multiple measures when it comes to dispersion. Now, range, it's very simple. It's a self-explanatory. Range is like you find out the minimum value, you find out the maximum value, and you find out the difference that will become the range. So if you want to find out what is the range of your sales, find out the minimum sales. For example, it's 100 and the maximum is 1000. So 1000 minus 100. Okay, so that would be your range of sales. Okay, it is simple to compute. It ignores all the data points. So if you have 100 data points, if you have 1000 data points, does not make any difference because it will just consider only the two values, the minimum and the maximum. In between, whatever number of values are there, it doesn't matter to this particular measure. Okay, so it is like quick to compute. If you just want to, if somebody is asking what is the how the data is spread, then the quickest answer is like range. You can say that it is somewhere between 10 and 1000 or between 100 to 10,000. Okay, so that would be your rough estimation. Okay, so now the second comes the quartiles. Now there is a difference between percentile and the quartiles. So quartiles basically it divides the data into 4 equal halves. So it's just like quarter. Okay. So as in an year, we have 4 quarters and every quarter divides the year into 3 months. So we have 4 equal quarters. So here also data is divided into 4 equal halves. That means 1/4, okay, of the data. So when we are saying 1/4 of the data, that means in the once the first quartile comes, so you will get 25% of the data below the first quartile. So for example, if I put the data like this, okay, so the first quarter it will have 25% of the data below this point and 75% above that point. Then you have another quartile which will again breaks the data into 25%. So it says that there is 50% of the data below this particular point. Now you can consider it as 50th percentile. You can call it as 50th percentile or the median. Okay, or you can call it as Q2, second quartile. So all these are like synonyms. So basically these these all mean the same. Then you have this is Q1, this is Q2, now this is Q3. Now this is another 25 and this is another 25. Okay, so the first quartile says that Q1, 25% of the data is below this. Second quartile, 50% of the data set is below the second quartile, and 75% of the data is below this third quartile. This is 25 plus 25 plus 25. This is all 75%. Okay. Now Q2 is located at the 50th percentile and it is equal to the median, and Q3 is equal to 75th percentile. Okay. Now this is how it looks. Okay, so these are the positions at which the data gets break. Okay, so these are the 3 important quartiles, Q1, Q2, Q3, which breaks the data into 4 parts. Now, again, to calculate these quartiles, we can use the percentile formula only. So for Q1, we use 25, for Q2, we use 50, and for Q3, we use 75 as as percentile. Okay, and then we can capture this Q1, Q2, Q3. Now, what we are doing is now, let's see, okay, we have divided the data into 4 equal parts. And now we are examining, so it is all about dissecting the whole data and then examining or analyzing that data. So at every point, at every quartile, we are seeing that, okay, what is the value and below which, how much amount of uh, data is available. Okay, how much amount of data is there. So Q1 is now, in this case, it is 11.5. So we'll get an idea that, okay, above this, there are 75% of the data. Below this, there are only 25% of the data. What is the middle point? The middle point is 118.5. Now you can compare this Q1 with Q2. Now you see that, okay, there is not much difference between Q1 and Q2. So that means there are very um, small increment in the values, are there, okay, between the Q1 and Q2. When you look at the Q3, now it is 123. Now let's suppose it is a higher value. Now you can say that, okay, much higher values are between Q2 and Q3. So like that, you can understand if you add again to this the minimum and the maximum, also, into this particular stack, okay, then you will even get a complete picture. So let's suppose minimum is 100. Now you can say that 25 percentage of the data, okay, uh, in the starting segment of the data is between 100 to 111.5. Then another 25% of the data falls between 111 to 118. Another 25 is between this particular range. And the final 25% is, let's suppose you have another value as max, and then you will find out how many percentage of the values are falling between this range. Okay. Now, where we were taking only one single range as maximum minus minimum, and then we are kind of guessing on the data. Now we can use this quartiles along with min and max, and then we can get even better understanding about the data. Now, another measure is known as interquartile range. In short, we call it as IQR. Now, this is like middle portion. Okay, so when I say the data, this quartile divides into 4 equal parts. Now, this particular middle portion is known as IQR, which is this is Q3 and this is Q1. So if you subtract Q1 from Q3, then you will get a interquartile range. Now, why is it important? Why we want to view the data in this way? Because see, if there are any extreme values, mostly extreme values will be in this or in this. Either there would be extreme values which is like on the lower side or on the higher side. So they may fall in these quartiles. Okay, but these are the true picture, okay, or the true values. Okay, and these so this will give me the good indication about the data, and it captures around 50% of the overall values. So the middle part is like more I would say common occurring values, right? So which is not either low or either high. So this IQR will give you another picture or another perspective of the data. So for example, sales. So sales could be as low as $100 per day, okay, or it could be as large as $10,000 per day, okay. But what is usual business, okay, and how much sales we are getting in any usual day, typical day? So that's something we can get it in IQR, and then if we want to understand what is that range, okay, then we can go with this IQR, which is Q3 minus Q1, okay, and it captures 50% of the data. The only thing why we go with IQR is because it is less influenced by the extreme values. Okay, now the next is the deviation from the mean. Guys, please stop me if I'm going too fast or if you have any questions. Okay, now deviation from the mean. So we know that mean is the central measure, okay, measure of central tendency. So it is kind of indication where the entire mass of the data is located. And we take that as a benchmark, okay, we take that as a middle location, and from there we will see that how other values are varying from the mean. Okay, so there are certain values which would be uh, lower than the mean, and certain values which would be higher than the mean. So the deviation could be on the left hand side and the deviation could be on the right hand side of the mean. Okay, so if the values are larger than mean, then the deviation would be positive, and if it is on the left hand side, the deviation would be negative. Okay, so here in this case, if this is entire my data, now this is my mean, and I want to understand how the data is varying from the mean, considering that mean is my central location. So the deviation is -8, -4, 3, 4, 5. With this, I can understand where exactly is on which side there is more deviations, whether it is on the left hand side or whether it is on the right hand side. Okay, so now to capture one single number out of those deviation, we call it as mean absolute deviation. Now overall, here in this case, I can understand where on which side the deviation is. If I want to quantify the overall deviation, then what I will do is, firstly, I will capture the deviation from the mean of each of these values. It could be negative and positive. Then I will convert that into a absolute values. Absolute values means all the negative values will be converted into positives. Okay, so I'll get only the magnitude, not the direction of the deviation. So here means this particular value is 8 units far from my mean. I'm not bothered about which side of the mean. I just want to find out what is the magnitude of the deviation. So for that reason, I took the absolute deviations. So all the negative values will become positive. Now this is my overall deviation of the values from the mean. But overall deviation would not make sense, because now let's suppose I'm considering only 5 values. Tomorrow I may consider 50 values. Later I may consider 500 values. So how to quantify, how to come up with a value which can explain me or give me some indication about the deviations. So as we seen that, okay, for any range of values, to get some indication about that range of values, we go with an average. So here also, for a kind of range of deviations, to get some indication of the deviations, we'll go with mean. So here the mean absolute deviation will give me a rough idea that, okay, the values are deviating plus minus 4.8. Sorry, plus minus 4.8 of the mean. Okay, so mean is 13, then I can say plus minus 4.8. So this is the kind of a deviation I'm seeing in my data, because 13 is the mean and this is my deviation, mean absolute deviation. So this will give me a quick idea. Now let's suppose from a business point of view, if I'm telling to the business like, okay, your average sales is $200 plus minus $50. So that gives a kind of a range, okay, from $15 till $25, whatever it is. Okay, that's a kind of a range. That's kind of a deviation in the values what I'm seeing. Okay, and that's how it will explain me the variation in the data. Okay, so now that is a very simple way of analyzing, and anybody who has some logical mindset can go and find out the deviation in that way. But now these are some of the very specific statistical way of finding out the deviation. One is known as variance. Okay, so in the variance, what we will do is we will capture the mean. So I'm talking about population variance. So that's the reason I've denoted it as mu. If I'm going with sample variance, now instead of mu, I will denote it as x bar. So first, whatever data you have, whether it is related to population or the sample, you calculate the mean of it. So in this case, I'm calculating the entire data, and then I'm calculating the mean on top of the entire data, which I have showing it as mu. Okay. Again, what I will find out, I'll find out the deviation from the mean. It would be positive or negative. One way of converting the negative values to positive is I go with an absolute. Okay, I'll go with an absolute values. Another way is you take the square. If you take the square, the negative values will be converted into positives. Okay, So here -8 has been converted into 64, -4 has been converted into 16. So I've taken the square of each of the deviations to understand the magnitude of the deviation, and then finally I summed it up, which is known as 130. Now, if I take the mean of this square deviation, now that is known as the variance. So in statistics, we denote it as this notation is known as sigma. So variance is known as sigma square. Okay. Now, why we need to do square and what we will get out of the square? It is again a debatable question. Okay. So in statistics, there are certain things which has been kind of we have to follow blindly. Okay. Just like the theorems or some kind of mathematical methods we use blindly. So here also we kind of need to understand or need to use these particular measures blindly. Okay. Now, you may say that, okay, absolute could have been better, okay, mean absolute deviations. But no, in statistics, it has been proved that if you use variance, sigma is considered as very important measure in statistics. There are two measures which are considered as very important. Entire statistics revolves around those two measures. One measure from a central tendency and one measure from the dispersion. So, which are mean and sigma, which is mu and sigma. And you might have heard about a company name, Mu Sigma. Okay, they are into, you know, they provide all the data science services uh, to the companies. Okay, so they have named it as Mu Sigma. So entire statistics revolves around these two measures, mu and sigma. And with these two measures, you can do a lot of things. Okay, and you will see in hypothesis testing and all those things, all these two measures will play an important role. So here, sigma square is nothing but it's a square of the this variance is nothing but the square of this sigma. Okay, and the sigma is known as standard deviation. So standard deviation and the mean, these are the two most important measures in the statistics. And one measure is measure of central tendency and another measure is measure of dispersion. Okay, so firstly, we have calculated the variance. Okay, then why variance and then why standard deviation? You may ask. Now see here we are scaling the values. Okay, because we are taking the square. Okay, of the deviations. So here we has deviation as -8, but we have took the square of it. And even after taking the average of the squared, still the values are at a higher scale, 26 scale, which is not making any sense with the real deviation. So again, to bring back to the same scale, what we can do, we take the square root of this. Now the square root of this variance is known as standard deviation, which is denoted as sigma. Okay, so now it would be somewhere 5 point something, okay, 5.7 or something, okay, 5.1. Okay, so square root of sigma is square root of variance is known as sigma, which is nothing but a standard deviation. Now you see the difference, okay. Now mean absolute deviation is what? Mean absolute deviation is 4.8, okay, which says that there is a deviation with the mean plus minus 4.8, okay. But here standard deviation, what it is saying, here the deviation is plus minus 5.1. So it is 13 plus 5.1. So there is a significant difference. Okay. Now, once we look at the larger amount of data, generally it has been proved that instead of MAD, if we go with standard deviation, roughly you will get a better results. Okay, better insights. Okay, those are very much closer to the real picture. So that's the reason most of the times we go with only standard deviation, not the mean absolute deviation. And you might have heard about Six Sigma, right? All these things. So all those things are kind of related to the standard deviation. So if you say that the data is deviating from the mean plus minus 1 sigma, so that means 1 into 5.1. If you're saying the data is deviating from the mean plus minus 2 sigma, so that means 2 into 5.1. So like that, when you talk about Six Sigma, so what it means is uh, your data, your range, the quality is lying between plus minus 6 standard deviation, and that plus minus 6 standard deviation captures around 99.9999% of the values. So don't worry. So we'll talk about that particular part in the empirical rule, which is a part of this statistics. Okay, so there we will understand what is 1 sigma, 2 sigma, 3 sigma, and 6 sigma. Okay, so here what we understood is now standard deviation is one of the measures which will understand the dispersion in the data. Okay, and the formula of this dispersion of this measure uh, is the square root of the variance. And what is variance? Variance is nothing but summation of the square deviations of the values from the mean divided by total number of data points. Okay. Now, if it is a sample variance, so instead of mu, we go with the sample mean. So we understood about what is population, what is sample in the last class. So the statistics is all about getting some understanding about the population with the help of sample. Now, the major rule is like we will talk, even we will discuss about the different techniques of sampling. Okay. So you have to choose the sample in such a way that it should represent your population. Okay. It should not be biased. It should not be a sample which collects only certain kind of units or certain kind of scenario from your population. So this sample should be a miniature version of your population. So once you choose the sample, you have to use appropriate measures, which we call as sample statistics. Okay, to get the picture of your population parameters. Now, for example, population parameters is, let's suppose, mu. Now, to get some indication about this mu, you will go with sample statistics, which is known as X bar. Now, in the statistics, you need to understand which one to consider as mu, which one to consider as X bar. Okay, so sometimes in the problem statement it would be confusing. So you have to very clearly understand the problem statement and you have to consider the appropriate measures. Okay. So we will talk about other parameters also. It's not just we will talk about only the mean. So if, for example, in the population, if we want to find out what is the deviation, so here the population parameter is called as sigma square. Here in the sample, we called as S square. Okay. Where here we will call as sigma, here we will call as S. Sometimes we will also talk about proportion, where we will talk about capital P. Here we will talk about small p hat. Okay. So, for example, population. If I'm saying 80% of the population, India population, they like Modi government. Okay. Now, how can I justify that particular statement? Somebody has given, and somebody like, some institution, they will go and say that, okay, verify if that statement is correct or not. What they are saying is really 80% of the population, India population, they are liking this government. So I cannot go and do this study on the entire population. So what I will do is I'll go and have a small sample. Okay. And in that sample, I will go and analyze it. So in that sample, whatever proportion is coming, that I will call it as p hat. Okay. So as if I go and calculate the mean on my sample, it is called as X bar. If I go and calculate the variance on my sample, then I'll denote it as S square. If I going and finding out the standard deviation on my sample, then it will be denoted as S. Okay. So in this way, whatever sample statistics I am calculating on my sample, I will, based on that, I can infer about the population parameter. So that's the reason this kind of analytics is also called as inferential analytics. Okay. So with this sample I can able to make statements. I can able to make big statements like, okay, 80% of the population are unemployed, or 20% of the population are below poverty lines. Okay, that kind of a statement I can make it without analyzing the entire population. So, when you are dealing with any problem statement, you have to clearly understand whether you are dealing with a sample statistics or whether you are dealing with the population parameters. Okay, so do not worry. Once we talk about the population, when we talk about the problem statement, at that time we will clearly discuss about all those things. Okay, so sample standard deviation, as I mentioned, is denoted by S. Okay, and the sample variance is denoted as S square. Okay, so where all the standard deviation can be used? Again, a very easy way of calculating these measures, uh, but but yet these measures will give you a lot of information. So it will give, for example, the standard deviation gives you an indication of the financial risk. Okay, so if you are capturing the risk some or the other way, okay, if you can measure the standard deviation on top of it, you can understand that how much is the risk going on. Okay, if it is like 4.5% or 10% of the risk. So that means your risk is varying, okay, by 10%. So whether it is safe or whether it is not safe, looking at the, whatever domain it is you are into, accordingly, you can qualify whether it is a higher risk or lower risk, whether your business is at a high risk or low risk. So if in bank, okay, the financial risk is more than 10%, then it is alarming, right? When compared to any other domain. So like that, you can understand the risk and you can find out, what is the amount of risk which is happening. Even in the quality control, somebody wants to have a want to maintain a good quality standards. Okay, so they will go and capture the data every day, okay, or every minute, okay, depending on how in what rate they are kind of manufacturing the products. Okay, and every time when they are kind of capturing the quality measures, again they can apply a standard deviation on top of it to see how much is the deviation. If it is very low, that means yes, your quality standards you are maintaining. Okay, so all the values are kind of very near. So it is like the quality standard is 22.5. Every time you are kind of between 22.3 to 22.6. Okay, and so that way your standard deviation would be very, very low. If your quality standard is sometimes it is 10.5, sometimes it's 12.5, sometimes it's 20.5, sometimes it's 30.5, your standard deviation will be high. So in that case, your quality standards is not. So in terms of quality control, so the person who is managing the quality, so the QA guy, okay, he will have those kind of charts where he will continuously monitor, okay, how the quality is kind of changing, okay, in terms of standard deviation. Okay, so if you have to compare any two populations, so there also you can go with standard deviation. So for example, let's suppose you want to find out the financial risk of two banks. Okay, there you calculate the standard deviation for each of the two banks, and then you can compare based on that, which is of higher risk. So for example, you want to choose any equity, okay, for your stocks, for your stock trading, okay, for your trading. So you just pick two stocks, compare the prices of those two stocks, and calculate the standard deviation. You can able to understand which one is more volatile, okay, where the values are varying too much. So as we discussed last time, if the values are varying too much, okay, if the standard deviation is too high or too large, so that means there is a high chance of making money. Okay, so there is high risk. Same time, where there is a high chance of making money, there would be a high chance to lose the money also. So it depends on your appetite, how much risk you can take. You can choose the right amount of stock, okay, right kind of stock. So for example, in this case, so just to understand how it measures the financial risk. So for example, you have two stocks, okay. um, Now the average return Okay, average rate of return interest of this particular stock is, let's suppose, 15%, and even the average return of this particular stock is 15%. If you have only this much information, it would be hard for you to decide which stock to pick up, right? Because both are giving on an average 15% of the returns. But when you add this standard deviation along with this mu, now comes the reliability part, which I was talking about. Okay, how uh, can you decide on the reliability? So now I'm saying this these values, rate of returns is changing by 3% here. Okay, and here it is changing by 7%. Now it depends. Now with this you can decide in which stock you need to go and invest. So if you are more of a risk averse guy, you don't want to take high risk, then you will go with the option number A. Okay, the first option, because there is not too much of variation in the rate of return. So it is 15 plus minus 3%. On the max, it will go to 18%, or as low, it will go as 12%. So you are very much covered there. If you are going with a financial security B, now the variation is 15% plus minus 7%. So it can go as high as 22% and as low as how much? 8%, right? 8%. So in this case, you should have a high appetite of risk. All right. So any questions, guys? Is the standard deviation clear to every one of you?
So, Srikant, you have
Mhm.
shown a lot of other things apart from standard deviation, like variance and
Yep, yep.
so are we going to use only standard deviation as
Most popularly, we use standard deviation and variance only. Okay. But not mean absolute deviation. But see, what happens is in the real scenario to the business, okay, we kind of provide all these measures. We'll also show them mean absolute deviation. We also show them variance. We also show them standard deviation. So if you provide more information about a particular state, then they can even get they will get more confidence on it. Okay, so if the mean absolute deviation is also saying is also high, and even your standard deviation is also high, then they will further get more confidence that okay, now okay, here the variation is too much. Okay, so but generally, for any kind of statistical analysis further, okay, as we move forward, we statistically we don't consider mean absolute deviation. We only consider standard deviation only for further analysis. But just if you are considering it as an independent standalone measures, then it's your wish. Either you can go with only standard deviation, because standard deviation considered than mean absolute deviation is more relevant, and it will give a better picture, and you will be more accurate in terms of providing those values. Okay, because standard deviation is used across the industry, to measure the dispersion. Okay, even in this talks and even this in financial risk, uh, all those areas, the standard deviation, even in the quality side, standard deviation is considered as a standard measure, for dispersion. Okay.
okay?
Yep. All right. So we were talking about Six Sigma and all those things, right? So there is a empirical rule. So there is a thumb rule, which these in the statistics, we state that if your data is normally distributed, so I'll explain you what does that mean. If your data is normally distributed, then it says that there's 68% of all your observation will fall within one standard deviation of the mean. So let's suppose you have a entire data, and you have calculated the mean and you have calculated the standard deviation. If you take X bar plus minus one standard deviation. Okay, then 68% of the data will fall in this range. Okay, if you are going with two standard deviation, then it says that 95% of the data will fall within mu plus minus or within mean plus minus two standard deviation. If you are going with three standard deviation, then it is 99.7% of all your observations will fall within mu plus minus three standard deviation. Now just imagine six standard deviation. Six standard deviation is like almost all the point. It is 99.999999. So and this Six Sigma is generally considered in the space of quality. Okay, now you might have heard about Lean Six Sigma, right? Even in the what do you call uh, black belt certification, okay, Six Sigma certification. So there also what generally people are taught is how you can improve your process in such a way that you will maintain your quality standards. Okay, so roughly in the manufacturing setup or in the process centric organizations, there generally we deal with all this Six Sigma and all. So there it says that okay, our quality standard, what we maintain, generally fall under mean plus minus six standard deviation. So that means 99.99999% of the times our quality is maintained. So Toyota basically was a company who has came up with this lean management or lean Six Sigma. So they used to maintain the quality in such a way that they were very confident in saying that okay, our quality standards what we maintain is 99.999% reliable. Okay, so why they were calling Six Sigma? Because of this particular empirical. So because Six Sigma says that within mean plus minus Six Sigma, 99.9999% of the values falls within that particular range. Now, when I'm saying this normal distribution or bell-shaped, so see if you have any continuous variable, okay, continuous column. Okay, so these are the values, okay, and these are the frequency basically. So if you take a range of values, for example, I'm taking a column whose range is between 10 to 100, let's suppose. So now this interval would be 10 to 20. Okay, in this 10 to 20 range, let's suppose I have 20 values. This is frequency, right? Now from 20 to 30, I have another 30 values. Now 30 to 40, 40 to 50, 50 to 60, 70 to 80, 90 to like that. Okay, I have some kind of a data. Now here, my data is following this kind of distribution, okay, which is not a completely bell-shaped. So here the assumption what we have to make is if your data is following a completely bell-shaped curve, so it is something like this, okay? Okay, and where your mean would be exactly in the center, okay, then that particular distribution is called as normal distribution. Again, about this distribution we will discuss later. Okay, now you see in statistics there's a lot of assumptions which you have to consider. Then only you cannot like blindly, you cannot just go and say that okay, whatever data is okay between this plus minus Six Sigma, this much data is lying, right? You cannot. The assumption is first is that your data has to follow a normal distribution. If it is not following a normal distribution, then there is a way, to convert that into a normal distribution. And then you can go and claim that, okay, this much percentage of the data is falling within this many standard deviation. Okay. Now, this kind of a bar plot, which you will plot, is known as histogram. Now, this is not a bar plot. Okay. It's a histogram which you can create only on the continuous variable, which we have discussed just now. The data, the variable has to be numeric. If you have a numeric data, then you have to convert that into intervals, which we also call as bins. Probably you might have done it in school days. Okay, we used to do that. Okay, so we need to create a bin, and then we need to go and categorize every value in these bins. So now these bins has to be continuous. Okay, this is 10 to 20 wala bin. This is 20 to 30 bin. Okay, this 20 to 30 bin you cannot place it here after 40 to 50 bin, right? It has to be in an order. Okay, so now that's kind of a plot is known as histogram. While we have seen a bar plot, right? So for example, if I say if I take any category, for example, if I take mm, product categories. Okay, so for example, technology, second furniture, third is like apparels. Now, is there any order between these categories? No order. I can place technology after furniture. I can put apparels in the beginning. Okay, so it doesn't matter. Okay, now if I go and find out in the data how many data points are related to technology, related to furniture, related to apparel, now this will become this is called as a bar plot. So difference between the bar plot and histogram is now these bar plots are not continuous. These bars need not to stick to each other. Okay, it can be independent and it can be placed in any order. Okay, in the bar plots. And in short, these bar plots are used in for categorical variable. Okay, and that too nominal, if you remember. Okay, what is nominal? Nominal means where the categories will not have any order or will not have any relationship with each other. So here the technology is altogether independent category, furniture is a different category, and apparels are a different category. While in histogram, all these intervals, they have a relationship, they have an order. So after 10 to 80 bin, there has to be a interval of 20 to 30. So that's the second category. You cannot place it anywhere else. So, and each of these bar plots has to be stick to each other because 10 to 20 and then 20 to 30. Is there any other number which will uh, lie between these two intervals? No, it is like continuous 10 to 20, 20 to 30. So in that way, all these bars will stick to each other, and this kind of bar is graph is known as histogram. Okay, so we will understand how in Python, for each of these kind of variables, how we should go and create the plots. Okay, so this is an empirical rule. Now you would be even thinking like, okay, there should have been any rule, for for the data which is not normally distributed. One way is like if it is not normally distributed, you have to go and convert that into a normal distribution, and then you can apply this empirical rule. The other way is like you can follow some other rule which is applicable even for distribution which is not normal. Okay, so this is for a normally distributed data or for approximately normal. Okay, so this is 1 sigma 68%, 2 sigma 95, 3 sigma 99.7. Even if somebody is following a 3 sigma or 4 sigma also, still it is good because 99 they are following 99.7 okay percent of the quality. Okay, and somebody who is claiming like 6 sigma is like, so there is very less chance of making any error. So if you know about this uh, Mumbai Dabbawala, okay, case. It is a very popular business case which people talk about in B schools. Okay, so are you aware of this Dabbawalas in Mumbai, guys? Anybody?
Yes, Sriram.
Yeah. So it is a very big network of people. Okay, and their job is to move the lunch boxes. Okay, of the people from their home to their offices. And all these dabbas, okay, look very similar. And they will just have number punched in, okay, in the back and some color codes. And they work so efficiently, okay, that they will pick up the dabba at the right time and they will go and deliver that dabba to the right place to the right person at the right time. Okay, and they have to move from multiple places. They will catch multiple local trains. They will you know walk. They will do everything. Still, they will able to deliver the dabba on time. So they follow Six Sigma. That's what is the use case. Okay, without having any monitoring mechanism, nothing. Okay, they follow 99.999% accuracy. So that's quality. They never ever have exchanged the dabbas. Okay, everyone has received the right dabba on time. So it's a business. So if you go and do some Google search, you will find that whole use case. Okay, still management people, they talk about this use case. Okay, so coming back, so if your data is not following a normal distribution, there you can go with this another rule known as Chebyshev's theorem. So here it says uh, it applies for all shapes of histogram, not just bell shaped. Okay, so here we follow this particular formula where k is nothing but whatever number of standard deviation we have to consider. So that would be the k value. And here the k has to be greater than 1. Okay. So for example, if k equal to 2, the theorem states that at least 3/4. So it is 1 by 4 equal to 3 by 4. So 3 by 4th of all the observations lie within 2 standard deviation of the mean. Okay. So accordingly, like that, okay, you can what is 3/4? 3/4 would not be 95%. It would be less than 95%. Okay. So, so if your data is not following a standard, normal distribution, then you can go with Chebyshev's theorem. It would be little lesser than your empirical rule. So where your empirical rule says that 95% of the values will fall within plus minus 2 standard deviation, Chebby theorems will say that it's 3/4. So what is 3/4, guys? How much percentage? It is 75%, right? 3/4.
Yes.
Yes. So it says 75% of the values falls within plus minus 2 standard deviation. So that much difference you will find, between empirical rule and Chebyshev's. Okay, and then finally, the last one is the coefficient of variation. Okay, so the coefficient of variation here, this is one single measure which will consider both standard deviation and as well as the mean. Okay, it is the ratio of standard deviation and the mean. Okay, so which will give you the overall picture about the relative dispersion of your data. Okay, and it is expressed as percentage when you multiply that by 100, okay, of that ratio. Okay, so look at this. If I give you only this particular information, okay, and I will tell if I ask you which one is better, okay, if the scales are also different, okay, in this particular scale, where the mu is 29 and standard deviation is 4.6, is this better? Or where the mean is 84 and your standard deviation is 10, is this is better? It's going to be a little difficult question to answer. Okay. Even see, I mentioned that, okay, you can rely on to increase the reliability of your mean, you should refer to this standard deviation, then you will able to get a better picture. So this is only applicable if your mean are on the same scale. If you are observing two different state or two different entities where the scale of the means are different, then to compare you can go with this coefficient of variation. So here I'm taking the ratio of this two. So here the ratio is 15.86, here the ratio is 11.90. So here you can consider that this is better in terms of dispersion when compared to this. Now here this will be, so this particular concept is used for, again in stock trading, where you are dealing with mid-size cap or bigger stocks, okay, comparing that with the smaller stock and then understanding, okay, where the volatility is higher. So if it is a smaller stock, then possibly you can go with higher coefficient of variation. If it is a higher stocks, if the prices are very high, then you can go with a lower coefficient of variation. So that kind of decision you can make by looking at this coefficient of variations. Okay, then comes the skewness part. See, what is skewness? I mentioned about the data which is normally distributed. So if the data is normally distributed like this, so these are values, X values, okay, and this is frequency, okay, Y axis. If your data is distributed like this, so that means your data is symmetric, okay, where mean is exactly in the center. So if it is like perfect normally distribution, then mean, median, mode, all the three M's will coincide with each other. It would be having a single value. Okay, so that's the property of normal distribution. So in the normal distribution, you can bisect the entire distribution into two equal halves from the center, from the mean. Okay, and usually you will get this kind of distribution when you do not have extreme values on either side. You have equal proportion of the values above the mean and below the mean in the same scale. Okay, so if the distribution is symmetric, then your mean, median, mode will be equal. But now, if your distribution is skewed means what? If you get some extreme values on the right hand side, so what will happen? Your data will be skewed on the right hand side. If your because your tail will get longer. So if you have extreme values here till here, okay, your tail will get longer. So in this case, the data would look like positively skewed. Okay, so if the median lies between mode and mean, mode is less than mean. So this is a very statistic way of defining what is right skewed and left skewed. A simple way is like if you have a long tail on the right hand side, then it is right skewed. If the long tail is on the left hand side, then it is a left skewed. So if you have a data like this, okay, where the tail is longer on either side, okay, then that data is called as skewed data. Okay, in that, if the data looks like this, then you cannot uh, follow that empirical rule. Okay, and later we will see that whatever statistical analysis we'll do, the biggest assumption we will make with the data is that it is normally distributed. So what we have to do is either we have to go and convert my data into normal distribution, okay, or else whenever we are capturing the data, whenever we are considering the sample, we have to make sure that that data behaves normally. Okay, it has to be distributed normally. Okay, so now one way is like you go and view the data. Okay, you go and plot that data and then see that you know how it is distributed, or else there is a measure in statistics known as skewness. Okay, skewed means like it is pulled at one side. Okay, so through this measure you can understand, it will quantify the skewness, and through that value you can able to understand how the data is skewed and to what degree the skewness is there, okay, in your data. Okay, so there is a coefficient of skewness. Okay, so coefficient of skewness is defined by this particular formula where mu is mean, sigma is standard deviation, MD is median. Okay, so you take this formula, okay, and then you can consider the skewness, measure the skewness. If your skewness, okay, is less than 0, then your distribution is considered as negatively skewed. If it is 0, then it is perfectly symmetric and you can consider that distribution is normally distributed. If it is greater than 0, then it is a positively skewed, okay, or rightly skewed. Less than 0, negatively skewed or skewed towards the left. If it is positive, value is positive, then it is known as positively skewed or skewed towards the right. Okay. Now, why is it important? See here, whatever we are doing, okay, whatever we are measures we are using, with these measures, we are trying to understand the data. Okay, and this is very important step, guys. If you directly start learning about machine learning without dealing with all those things, just imagine, okay, you will not able to understand the quality of the data, and you will just feed the data as is, and all your output will go wrong. So now statistics is the base of your machine learning, guys. So why it is a base? First of all, to understand those algorithms, you need to understand the statistics, and even to understand the data, you need to understand the statistics. Okay, because with each of these measures, firstly, you will understand the quality of the data. Okay, and once you understand the quality of the data, you should able again, on that basis you will understand lot of different variations. You will understand the state of that the basically the condition of that particular state. Okay, so a lot of insights will also you will also derive out of that data. So now let's suppose your data is skewed. So what does that mean? What it implies? If your data is positively skewed, that means there are some extreme values on the right hand side which are extremely high, which is skewing my data. Now you have to go and examine those extreme values. You have to go and check with your business stakeholders saying that okay, on the right hand side, certain data values are extremely high, so which is skewing my data. Do you want me to go and consider those values, or can I take it out because it is impacting my statistical analysis? If they are one or two, then you can go and remove that. Otherwise, you have to find a way to convert those extreme values into a uh, other other different scale, which will convert your data to a normal distribution. Okay. So this is how, manually you can go and calculate. So this is your mu, this is your median, this is your sigma. Okay, go and compute those, go and substitute those values into this particular equation and compute, and then you will find out the skewness. So if this is the case, then it is negatively skewed. If this is the case, it is uh, symmetrical, it is normally distributed, and if this is the case, then it is a positively skewed. Okay, now another measure in the dispersion is known as kurtosis. Okay, so I'm just making you familiar with these terms, okay, because these terms I will again consider, okay, while talking about some other concept. Okay, so you should understand what these terms really mean. Okay, so kurtosis. Now here, uh, the skewness, it was measuring the basically the tail, okay, on which side the tail is longer. Now, kurtosis basically measured this peak. Okay, basically it explains you about the peak, whether the peak is very peaked, okay, whether it is very sharp, or whether it is normal, or whether it is broad. Okay, so with this particular kurtosis, you can able to understand whether your distribution is leptokurtic, means your peak is high and thin. So high and thin means what? So there is kind of the data is not having too much of spread. Okay, so it is very narrow range. Okay, and most of the data is kind of located in the center. Okay, that's the reason the frequency is higher. Okay, for certain values, and that's the reason I'm finding out a very high peak. Okay, with a very thin spread. Second is known as mesokurtic. Here everything looks normal, perfect. Okay, here the peak is not too high and even the spread is not too broad. Okay, so this is known as mesokurtic. Okay, so perfectly, this is also known as normal distribution. Okay, so normal distribution is very normal. Okay, and where everything is like properly normally distributed. Okay, and you can cut this particular curve into two equal parts. Now comes the platykurtic. It looks like a plateau, so that's the reason it is called as plateau, where it will have a flat and flat peak. Okay, and with a too much of spread. So here the range would be too large, and most of the values in the center will be repeating. Okay, it's not, and again the range of those values would be relatively larger than compared to leptokurtic. So again, with this single measure, you can able to understand the peakedness of a distribution. Okay, so for understanding the skewness in the data, we go with skewness, and to understand the peakedness of the distribution, we go with the kurtosis. Again, from the interview perspective, people may ask, right, which measure is used where? Okay, for what? All right. So again, in the kurtosis, I've not shown you the formula. So formula is a little complicated, but you understand that, okay, if it is negative value kurtosis, then it is considered as a leptokurtic. If the kurtosis value is 0, then it is mesokurtic. If it is positive, then it is known as platykurtic. And in Python, it is just one single syntax. Okay, you just pass that syntax, pass the data to that particular syntax or function. It will give you the kurtosis value. Now, finally, the box and whisker plot. Okay. So by now we have seen that, okay, we are using quantifiable measures, okay, to understand the distribution about the data. Now it is more of a visual representation of the data, which we can have by using this box and whisker plot. Okay. Again, these plots are, it is very common plot, which is used for analyzing a particular state. Okay, because it one single plot will able to give you a complete picture about your data, about the distribution. Okay, so we talked about quartiles, we talked about minimum and maximum. So this box plot looks like this only. Okay, it will create the box in between, and these are known as whiskers. Okay, so box and whisker together will give you the complete indication about how your data looks like. Okay, if your Q2 lies exactly in the center, okay, so then that means it is your data is normally distributed. If your Q2 shift towards left, okay, then in that case, you can consider it as a positively skewed. Or if it's the other way, then you can consider it as a negatively skewed. So in that way, okay, see if it is shifted this side, then this is a long tail on the negative side, then it is considered as a negatively skewed. So with this one single box plot, you can able to understand how your quartiles look like, how your median look like, and how your distribution look like. Okay, so this is the visual representation of the data, the box plot, and here just I'm showing that, okay, how this position of this median will tell you, whether your data is skewed or not skewed. If it is exactly in the center, it is like not skewed, it is symmetric. If it is pulled towards either side, then that means it is a skewed data. All right, so any questions, guys? So these are the measures of central tendency and measures of dispersion. Is everything clear? So what I have explained you are just the terms. Okay, and I've shared you the material. You can go through the material. I've shared it today morning on the Telegram channel. So go through that, read about each of these measures. So I have created those notes uh, in a very layman terms. Okay, so I hope you will understand it easily. So go through it, understand these terms, because these terms I will kind of repeat. I will take it multiple times. I'll refer multiple times as we proceed and discuss about other concepts. So all these terms has needs to be in your mind. So whenever if I'm taking out these terms, you should able to relate what exactly I'm trying to convey. Okay. All good, guys? Any questions? Any comments? Any thoughts? Nothing? So sometimes the silence sounds very dangerous to me. So I don't know whether you have got it or you didn't get it at all. So guys, your silence I'll take it as yes, okay, that you are getting everything. Okay. So if I'm wrong, then please speak out. All right. So okay, so from the next class, we'll get into hypothesis testing. Okay, and there we will cover these topics. But before that, I will show you all these measures, how you can calculate using Python. It's a very simple way. Just there is one single function you have to use, and then you can able to calculate these measures. Okay. All right. Okay, so the institute has asked me, to check with you guys like that you want the class tomorrow or not. Tomorrow is a festival, right, Ugadi? I am okay to take the class tomorrow. If you are, then we will have the class. If most of you are not okay, then we can take the off. I know we are taking off too often, so I don't mind taking the class tomorrow, guys. Okay, so if anybody has a concern, okay, of not having class tomorrow, please send the message on Telegram, or else you can convey it to the front office. Then accordingly we'll plan it. Okay. All right, guys. Then thank you. Have a nice day. Take care.
Thank you.
Thank you. Bye.
Yeah, bye.